So the schemes we have discussed, all the schemes that encode the bit into symbols or the signals, receiver has to know when one symbol is starting and other is ending, so that the next symbol begins to correctly decode the bits. This is the responsibility of the receiver. If you have long series of zeros, how can a receiver tell? It will be difficult to tell the bits apart because there are a number of zeros. So the only thought is we can have an accurate clock like we have in GPS, the atomic clock. Then it can easily tell where the symbol is ending. But it is very, very expensive. So the strategy would be, we can send this clock signal using a different channel. That is, we can send a separate clock signal to the receiver. One will be for data, one will be for the clock signal. So now the sender will know, sender and receiver will have same clock. It can easily find out where the symbol is starting, where the symbol is ending. But the problem is, if you are using another clock, why not to use it for the data? Why are you using single channel for sending only the clock signal? We can even use it for sending data. So the idea is, a clever idea is, we can mix the clock signal with the data signal, because the clock can only be used to find out where the data is there. So we can mix the clock signal with the data signal by using XOR. We will not need any extra line, which we were just discussing to send the clock signal. So the clock will make the clock makes a clock transition in every bit time. So it will run at twice the bit rate, because the clock is making a clock transition in every bit time. And since we have XOR the clock signal with the data signal, XOR you can see on the right, I have shown you the truth table. So when it is XORed with a 0 level, when we have 0, 0, it will give you 1. When you have 1, 1, it will give you 1. If they are different, 0, 1, 1, 0, you will get a 0. So when XORed with a 0 level, it makes a low to high transition. That is simply the clock. Okay. So the transition can be termed as a logical 0. When it is XORed with a 1 level, it will be inverted. And now it will make a high to low transition. So the transition is a logical 1. Logical 1 here. What I am trying to suggest here is that whenever you see a 0, it will be like this. Whenever it will be 1, it will be like this. The whole story is this. So you see here, whenever we have 0, it is going like this. Whenever we have 1, it is going like this. Take anywhere. 1, so it is going like this. Again we have 1, then we have 0, so it is going down. So this scheme is called Manchester encoding. This scheme is called as Manchester encoding, and this was used for classic Ethernet.